So, hello, my name is Sarah Brown. I'm a second-year PhD student from the Embodied Learning and Experience Lab at the University of Florida. I'm here today with my co-authors, Dr. Sharon and Dr. Quek, and this is the research I'll be presenting. Instead of reading out the long title, I'll instead summarize it. It's analysis of gestures produced during storytelling to determine the beginning of design applications for our envisioned storytelling system. So the inspiration driving this research is the one for a story authoring system where, as you tell a story naturally with your gestures and your speech, it understands your story and can start visualizing for you on a screen where your ideas can be shared with others. So as you discuss and create it, it comes to life. People can watch it unfold together. In terms of existing storytelling systems that incorporate the use of hand gestures, there tends to be three kind of general categories. The system could allow you to perform a specific gesture during story consumption to enhance engagement, such as responding to a quick-time event with a gesture. The gestures could control or manipulate an object of the story that is being told or made, like a puppet. Or gestures can be performed to contribute to storytelling scenarios where your gesture has a meaning, but the result is interaction to an existing scenario. Our work differs in that we focus on how to interpret stories from naturalistic gestures. So, of course, that means we need to understand what kinds of gestures there are. For this, we cite David McNeil's gesture taxonomy as it's one most commonly used in literature. They include iconic gestures, which are representational in nature and used to invoke images, metaphoric gestures, which are like iconic gestures because they are representational, but they tend to represent abstract gestures. Then we have deitic gestures, which are essentially pointing gestures, and like the previous presenter mentioned, there are beats, which are gestures that tend to naturally follow the flow of speech. So in our research, we began specifically with looking at iconic gestures. These gestures are representational in nature, they bear images, and are critical to oral storytelling in the way that they can describe objects and scenes and actions and so on. And just to provide a few examples, you can be acting out an action, showing the size of something, showing characters performing things, and so on. And it's also important to understand gesture features, so what aspects of gesture makes us understand what it means. Previous research in this regard, such as that performed by Kopp, Tepper, and Castle in 2004, investigated the relationship between the features of iconic gestures and their image-describing meanings to inform a conversational agent. However, their research focused more specifically on a conversational agent that gives directions as opposed to telling stories or something more qualitative in nature, I suppose. And then Dr. Quek observed that individuals will occasionally repeat gesture features for certain meanings that convey as they speak, which are coined as catch bits. So perhaps then we can start to think that conceptual meaning can be derived from the features of gestures themselves. So our specific research questions were, one, are there commonalities between the conceptual meaning and form features of iconic gestures, specifically in storytelling? And how can these inform the design of gesture-based storytelling systems? So to answer these questions, we conducted a gesture elicitation study in a conversational context. It's important to note it wasn't a traditional gesture elicitation study. In the sense, we didn't constrain the participants to perform gestures towards a certain task. Instead, we asked them to tell stories in a more conversational and broader sense. We had 17 participants, 15 male and 2 female between the ages of 18 and 34, that were recruited from undergraduate courses at the University of Florida in the Computer Science Department through the SONA participant recruitment system. Our basic protocol was to have the participant watch a cartoon and then sitting down with the researcher in a conversational context, have them retell the cartoon as though the researcher had not seen it. So we're getting a pure retelling of all the events from that cartoon. This was video recorded from 2 angles. One is like a main view, one to act as a backup recording. We repeated this for 5 short cartoon scenes and 2 5 to 8 minute shorts. These methods were also used by McNeil to collect gestures from a baseline stimulus for comparison. And for the specific analysis I'll be presenting today, we looked at all retellings from participants of the Looney Tunes short Box Office Bunny, which, as a quick synopsis, was about Elmer Fudd and Daffy Duck teaming up to chase Bugs Bunny through a movie theater, and of course, as it does in Looney Tunes, hijinks ensue. So now we'll go into our data analysis. The first step of which being the extraction of all iconic gestures from the participant videos of those retellings of the cartoons. It's important to note that iconic gestures and the identification of them is somewhat subjective in nature, so we use 2 to 3 coders to identify each iconic gesture in each video, and had them include a score of confidence of iconicity to indicate how sure they were of that gesture being iconic, and we then used averages of those scores to filter out gesture instances with low confidence. So afterwards, we excluded all gestures below the median, which left us with 65 gesture instances, and we coded for their conceptual meaning. I won't describe all of these in detail, but these are, as emerged from our analysis, the different meanings provided by the gestures we extracted from the videos. The ones I have bolded here had a minimum of 4 instances across 4 participants and are presented in our results. And then, with all those gestures, we also went ahead and coded their gesture form features. We used the form feature analysis scheme developed by Church and recommended by McNeil, and abstracted those to higher final categories. The 5 final being candidates, so it was one hand used or both, what the motion of the gesture represented, the direction hands were moving, such as unidirectional or bidirectional, what the hands themselves represented, and what shapes were the hands. For each final gesture concept, only form features with noticeably high percentages were presented in these following slides, but if you're interested in full results, they're of course included in our paper. So movement gestures were those that basically showed the relocation of characters from one place to another. We noticed that most of these were simple motions, as if there was no secondary motion, like in a couple instances we had that kind of cartoon rolling thing that would happen in Looney Tunes often. We also noticed that the hands tended to represent the characters performing the movement. Character actions were actions performed by the characters themselves. So, for example, Bugs Bunny eating a carrot. For these, we noticed the motion tended to represent the action being gestured, and the hands often represented some part of the character, such as their actual hands, or in a few cases, their feet. We noticed that for this concept, other features were far more divergent and were heavily tied to the specific action being portrayed. Relative position gestures were those that showed an object being placed in relation to another. For these, all instances were specifically an object being placed above another object. The movements tended to be unidirectional, and the hands tended to represent the objects. And in most of the instances, the hand shapes were flat, with some cases of them being curled. One limitation of this result is that this sample is mostly composed of gestures describing a scene at the beginning of the short, where movie theater is sort of unrolled over Bugs Bunny's rabbit hole. Dimension gestures we identified as gestures in which a specific dimension, such as length, width, or height, of an object was described. This was notably the most consistent of all of our conceptual meanings. Both hands were always used. The motion held no real meaning. The direction of the hands were primarily mirrored. The hands represented the two bounds of the dimension, and the hands tended to be flat with some that were pointed. So by observing these trends in form features, we can start piecing together what a system needs to understand when identifying or interpreting storytelling gestures of various meanings. For example, for gestures describing movements, systems may need to understand hand motions as possible paths for objects or characters. For actions, again, it was hard to find consistent patterns in form features since they were highly tied to specific actions. And thus, further research is needed to perhaps develop a taxonomy specifically for actions to account for all different types. But for gestures describing dimension, systems could potentially identify them from the form features we observed, so that mirrored movement of both hands being used in that kind of flat parallel nature. And actually, we have proceeded since this paper with development of a gesture-based story authoring prototype for dimension describing gestures using the form features uncovered in this work. It was developed in Unity with the open-close plugin from the CMU Perceptual Computing Lab. So in conclusion, for gestures of some conceptual meanings, there are consistent form features that could be used to interpret them for storytelling applications, and future work should expand on how gestures convey meaning in storytelling contexts and further identify what gesture features are important in the design of gesture-based operating systems. Thank you for listening, and thank you also to ICIDS for funding this research.